Sources of Electricity by Chan Yin, Glenn Yeo, Zhang Ziyiheng, Lim Min Yang, Terence Peng, Sabin Moses. There are 5 types of DC sources that can be used to produce electricity. They include light, friction, chemical action, heat, and pressure. Firstly, electricity is produced when light strikes a photosensitive surface or substance. The intensity of light determines the number of electrons emitted. The higher the frequency of light, the more energetic the electrons. An electric potential is produced as the photosensitive metal becomes positively charged when electrons are lost. A photoelectric cell or photovoltaic cell or solar cell functions on the photoelectric principle. Output voltage is relatively small. It is then amplified to a usable level by amplifiers. For friction, potential difference is produced by transferring electrons from one body to another through friction. This diagram shows a long Van de Graaff generator that is subjected to frictional forces. It is difficult to maintain voltage generated by this method. An electric potential difference is produced when two different substances, metals or materials made from metals, are submerged into a solution that creates a stronger chemical action on one than the other. As such, when a conductor is placed between, electron flow is created to neutralize the charges. Simple voltaic cell, an arrangement consisting of electrodes and electrolytes. Electrodes consists of 2 metallic substances. The solution is the electrolyte. Electricity can be generated by heating the node where 2 different metals are joined. Chromyl is positive and alumyl is negative. Electron moves away from the node in chromyl and moves toward the node in alumyl. This generates a flow of electrons. The compression of crystals generates electron flow while decompression achieves the opposite effect. This effect changes mechanical energy to electrical energy. The water-to-acid ratio in a fully charged cell is typically 25% acid, 75% water. Primary cells are non-rechargeable while secondary cells are rechargeable. To check the charging state of a secondary cell, specific gravity is measured. Advantages of primary cells are: more compact and convenient, lower production cost, less prone to thermal runaway, used for smaller mechanism, better suited for single-use applications such as guided missiles. Disadvantages of primary cells are: low voltage and low power output, shorter shelf life, high drain, uneconomical. They produce much more waste than rechargeable batteries. Advantages of secondary cells are: low cost for long-term use, high efficiency, high charging and discharging rate, tolerance to charging and discharging, high cell voltage, easy state of charge and discharge. Disadvantages of secondary cells are: high production cost, bulky, memory effect, more prone to thermal runaway, battery life shortened, charger cost, lower energy density and less exotic chemicals used.